Here's what we will do today. We will build a Wi-Fi mesh with OpenWrt. I bought a couple of these Asus Lyra mesh access points here. Got them real cheap on eBay. I paid 25 bucks each. Great Wave 2 Wi-Fi 5 devices with 3 radios inside. Multi-user MIMO, mesh and everything. Difficult to get, however. They are end of life from a sales perspective. I flashed them with OpenWrt and built a Wi-Fi mesh along with some more Wi-Fi access points that would otherwise collect dust in a box, like 2 of these RJC7s, a Xiaomi Mi router, a Belkin RT3200 and some custom built devices. My Wi-Fi mesh is as big as I could build it. I actually spread those access points everywhere in the house and also in the garden in order to make it a bit larger. Overall, I have roughly 10 nodes in the mesh. On the mesh, I have 3 different Wi-Fis which are called MIoT, M-Guest and M-LAN. If you have read the title or description of the video, you might wonder, what has Batman to do with all of this? First off, this is not about the guy with a deep voice who runs around in tights. We are talking about a network protocol here. More specifically, a mesh protocol. Batman is short for Better Approach to Mobile Ad Hoc Networking. Why would we need or why would we want that Batman protocol? Maybe you've seen my other videos about Wi-Fi mesh. In the first episode, I showed you how to build a mesh with OpenWrt. It's actually really easy and only takes minutes or an hour at most, I would say. If you only have, let's say, 3 Wi-Fi mesh nodes and 1 single Wi-Fi name or SSID as it's called, then you don't need anything else. You're fine with the basic functionality of mesh in OpenWrt. If you can run Ethernet cable between your Wi-Fi access points, then you don't even need a mesh at all. You're much better off using a wired installation like I proposed in this video here, link up there. So when would Batman Advanced be a good choice for you then? It does make sense if you have one of the following use cases. Maybe you want to go big. So by big, I mean really big. Like rather than planning for 3 or 5 nodes in the house, you want to build a mesh for your neighborhood, or for the valley, or the town, or city, with potentially tens or hundreds of nodes. In this use case, you would probably have multiple nodes that provide internet access, and hence you would need a protocol that can figure out which node has the best connection to the internet. Definitely a use case for Batman Advanced. And it's proven that it works. Have a look at the German Freifunk community. They are using it all over the country in meshes with up to hundreds of nodes. Second use case, and that's valid for any size. You have multiple Wi-Fi names or SSIDs, such as IoT or Guest or Wi-Fis for different groups of users. In this case, you would need to be able to use VLANs over the mesh. In my second Wi-Fi mesh episode, link up here, we had used GRETAP for that. But GRETAP is a point-to-point protocol. Batman Advanced can do VLANs over the whole mesh, by default, out of the box. And it's actually very easy. It can be done in 5 minutes. Third use case. Maybe your mesh is not all Wi-Fi. Look at this diagram. We have a 3-node Wi-Fi mesh here that is connected to an internet gateway. And maybe we are extending the mesh on the other side of the gateway. And maybe we have 2 or 3 of these. In a non-Batman mesh, the traffic would go off mesh in the middle. In a Batman Advanced installation, the mesh could go over the whole network, including the wired part. Actually, there is a 4th use case, and that is an aspect of the Batman protocol that is, in my opinion, often under-evaluated. As the Batman Advanced protocol can do VLANs, it can do something quite exciting. It can actually transform your whole network into a giant managed switch. You could plug in devices over wire or Wi-Fi or mesh into any of the VLANs at any point. So you could in fact use the Batman Advanced protocol if you want to do VLANs, but you don't have a managed switch. Very exciting. Cool. We have seen that the Batman Advanced protocol basically solves 2 or 3 shortcomings of a basic Wi-Fi mesh. First, it is a protocol that helps solve the basic challenge that you have in a mesh as opposed to a point-to-point network. That is, helping the packets to find their way to the right counterpart. A little bit like the traveling salesman problem really. And second, as it can do VLANs, we can have multiple Wi-Fi names go over one single mesh. Now let's see how we can get hold of it and how we can install it. It only takes 5 minutes really. If you already have your OpenWrt configured, like in one of the last episodes, then you can skip the next chapter and fast forward to this time marker here. If not, then I will show you real quick in the next chapter how to prepare your OpenWrt router and access point for mesh. I won't go into every single detail, but just outline the necessary steps. For a detailed explanation, please watch the first episode. The blueprint is as follows. We will have 3 Wi-Fis called MEIoT, MEST and MELAN. Each one of those has their own network and firewall zone and will be replicated, bridged or repeated if you want on all other access points over the Wi-Fi mesh. Alternatively, we may have something like this. If our internet gateway does not have Wi-Fi, then we may as well include a wired section in the mesh. That's a big advantage of using Batman Advanced. You don't have to go off mesh at the intersection between wire and Wi-Fi if you have wired sections. In this example, the middle part would still be part of the mesh, but rather than going over Wi-Fi, it would go over Ethernet or maybe even a VLAN. First, let's see the steps that we need to do on all routers and access points that participate in the Wi-Fi portion of the mesh. In order to be able to use the Wi-Fi as mesh point, we need a specific version of WPAT. For example, WPAT-mesh-OpenSSL or WolfSSL. So let's go to System, Software, and then install one of those. Now we can go to Network, Wireless, and click on Add next to the desired radio. I use a dedicated 5 GHz radio for that, as my Lyras have 2 of them. Down here in the interface configuration, I select 802.11s for the mode. I'll give it a name in the Mesh ID field, but leave the network blank for the time. We'll attach this to the Batman network later. In the Wireless Security tab, I select WPA3-SAE and type in a secret key. That's it for the moment. If you already have a mesh like this, then you would see the existing nodes down here. Now, let's see how the config on the Internet Gateway differs from the config on the so-called dump access points. Let's start with the Internet Gateway. That's the router that connects you to the Internet. You can see here that I have 3 interfaces called IoT, Guest and LAN. They all have static IP addresses, and if we go over to the DHCP tab, then you can see that each of those serves IP addresses on their own subnets. Also, each one of those is assigned to its own firewall zones with different policies. Furthermore, there is a WAN interface, which is the default gateway. In my case, it's called PPPoE. That's of course how we get to the internet. All other interfaces should not have that box ticked. If that main router or internet gateway has Wi-Fi, then we would also have Wi-Fi SSIDs, here under Network, Wireless. Down here, you can see which network they are attached to. That's the link between the Wi-Fi and the network interface. The guest Wi-Fi is on the guest network, the IoT on the IoT, and so on. Now let's have a look at the dump access points. Setting those up requires a bit more time. I create the same interfaces like on the Internet Gateway here, just this time I select unmanaged or DHCP client as a protocol. I suggest that you set this to DHCP client in the beginning, even if you want to change it later. That's actually an easy way to check everything. If everything goes okay, then these interfaces should get IP addresses over DHCP from the main router. If they don't, then something's wrong. When you create the interfaces on the dump access points, then you don't assign them to a firewall zone. They will just be bridged on layer 2. All IP traffic and firewall will be handled on the main router. Leave the device unspecified for the moment. We will link this to the right Batman interface later. Now, when you set up the Wi-Fi under Network Wireless by clicking again on Add next to the desired radio, then this is where you would actually link the Wi-Fi interface with the interface that we have just created. So I would link the MEIoT Wi-Fi to the IoT network, the MEST to guest, and so on. Now for the LAN and WAN. We don't need a WAN interface on those dump access points. We have the WAN interface on the main router. So let's delete it. The LAN interface in turn should not have a static IP, but rather have an IP served by the main router. So I changed the protocol to DHCP client. Do not click on switch protocol, that would commit the change immediately. We need to configure a couple more things. At the moment, I'm connected to this device with an Ethernet wire. Hence, the LAN interface has a device attached, in my case BR-LAN. I leave it that way for the time being. Just on the firewall setting, I remove the firewall zone, and on the DHCP server tab, I deactivate the DHCP server by ticking the Ignore interface box. Click on Save. Don't save and apply yet. We might want to check on the Devices tab if every Ethernet port is assigned to the right interface. In my case, I want both ports to be on the LAN. One port is currently connected to my main router and the other one to my PC. For a dump access point, they should all be connected to the LAN side. Therefore, I changed the settings for the BR-LAN bridge so that Ethernet 0 and Ethernet 1 are both on the LAN. Once I click on Save and Apply here, then the following happens. My access point tries to get an IP address over DHCP from the first router, and also my PC gets an IP address in the same range. As now we are both in the same LAN, I need to wait until this goes through. Plenty of time. I have 90 seconds before everything gets rolled back. Once I have the IP address, then I can check on the main router to see which new IP my access point has. And once I connect to the web interface of that access point, then the changes get applied because Lucy has confirmation that we could actually reach it. Otherwise, the changes would just have been rolled back. All that's left to do on this access point is to stop and disable some services under System Startup, namely the DNS mask, ODHCPD, and firewall services. That's it. Guys, I've been rushing a little bit over this as I have covered that part in a lot of videos already. If anything is unclear in this section, then please check the related videos. Here's what we have so far. We have a main router with a WAN interface, 3 interfaces called IoT, Guest and LAN. Potentially 3 Wi-Fis with similar names attached to the respective interfaces. Furthermore, we have access points, basically Wi-Fi routers where we have stripped firewall, DNS, DHCP server and IP routing, with the same interfaces, but of course no WAN interface. The access points have a Wi-Fi mesh and the main router may or may not have one. Now, let's do the B.A.T.M.A.N part in order to connect everything. In order to install the BATMAN Advanced protocol, we can log into the web UI of our OpenWrt router or access point, which is called Lucy. Then we go to System Software. If you type B.A.T.M.A.N, you should see these software packages here. If you don't see any, then just refresh the list by clicking on Update List. The one we are after is the Lucy-Proto-BATMAN-adv package here. At the time of making this video, in April 2022, chances are that you can't find that package. The reason is that it is brand new. If it is there, just click on Install next to it. If it is not there, then you may download it from my GitHub server. The download location is in the description of the video. In this case, please first install the kmod-batman-adv package, and once you have done that, click on Upload Package, browse to the file that you have just downloaded, and then click on Upload and then on Install. Awesome! At this point, you might need to reboot your router or access point, just to make sure that all protocols are available. Once your device is back, then please go to Network, Interfaces, and click on Add New Interface. If everything went well, then you should have an option B.A.T.M.A.N device here in the protocol drop-down list. Let's name the interface BAT0 and select B.A.T.M.A.N device as the protocol. Then click on Create Interface. You notice there is this additional tab over here named Mesh Routing. Let's click on it. We really don't need to change many options here. Most default values will probably suit most cases. However, I prefer to tick the box bridge loop avoidance in order to avoid endless loops if ever a packet turns around in circles on the mesh. I also want to select a value for the gateway mode. Set this to server on your router or internet gateway and leave it blank on the other access points, or leave it to off. Now click on Save. If you click on the Unsaved Changes icon up here, then you can actually see the changes that will be made to the system. Perfect. Adding the Batman network is a 3-step process. We have done the first step by creating the BAT0 device. You can actually see this if you go over to the Devices tab here. Here it is, BAT0. Back to the Interfaces tab. The next step is to actually create an interface that is linked to the BAT0 device and carries the mesh traffic. Let's again click on Add New Interface. Let's call the interface, let's say BAT-Mesh, and select Batman interface as the type. Please do not select the BAT0 device in this drop-down here. Leave it blank for the time being. I'll explain in a second. Once you click on Save, then you should get 2 additional options here. One is called Batman device. This is where we select the BAT0 from the previous steps. And the other one is Override MTU. Leave this blank for the time being. I'll explain it later. Please do not change any of the other values yet. I'll explain everything. Last step, now go over to Network, Wireless, and this is where we actually link the Wi-Fi mesh to the Batman network. Just keep going, I'll explain everything. Select your Wi-Fi mesh from the list of wireless networks and click on Edit next to it. Down here, under Interface Configuration, we can select the network which our mesh is connected to. In my case, that's the LAN. From this drop-down list, I select the BAT-Mesh network that I have created in the second step. Also, please go over to the Advanced Settings tab and untick the box Forward Mesh Peer Traffic. We do not want the mesh interface and hence OLSR, Optimized Link State Routing, to determine the path through our mesh. That will now be handled by Batman. Cool. Now click on Save and Save and Apply. On nodes that are connected to other mesh nodes over Ethernet, we would repeat step 2 and create another Batman interface. In my case, I called it BAT-Wire and attached it to an existing bridge called BR-Management. That's actually my management network, which in turn here on the devices is bridged with Ethernet VLAN 39. You might want to use plain ETH0 or an existing VLAN for this. Depends on your config really. On OpenWrt version 19, you can do this as well. Let me show you an example how I run the Batman network over an Ethernet wire. In my case, this is a VLAN, but you could select plain ETH0. Just make sure that you don't tick the bridge tick box here. The Batman interface does not work if it is a bridge itself. You may attach it to a bridge in version 21, but it does not have to be a bridge itself, like in version 19. But let's stop here for a second. We have done a lot of click here, click there. Let me quickly explain where we are at this stage. We have now added the batman-adv device to all routers and access points participating in the mesh. We have assigned the interfaces that carry the mesh traffic to an Ethernet port on the wired portions and to the Wi-Fi mesh on the Wi-Fi portions. For nodes that participate in both Ethernet and Wi-Fi mesh, we have created 2 interfaces. So now we have a Batman-Adv network spawning our whole network. Batman-Adv will take care of all the discovery in routes in that mesh. What we need to do next, and actually as a last step, is that we bridge the interfaces and hence the Wi-Fi networks to the right Batman-Adv devices. Pretty much the same like with Ethernet VLANs. I have decided to use the following networks on my mesh. And they of course correspond to the VLANs that I have been using in other videos. 3 for IoT, 4 for guest, and 99 for the LAN traffic. In order to do this, we will now assign the right network interfaces to the corresponding Batman-Adv device. Let's actually create a bridge for each one of those. First IoT. I go to Network, Interfaces, Devices tab, and click on Add Device Configuration. The type will be bridge. I create a bridge here because we might want to attach multiple interfaces to that device. First bridge is called BR-IoT. In the Bridge Ports drop-down box, I type in BAT0, because the IoT network shall flow over the Batman network. And then I add .3, because I want to use the network number or VLAN 3 for IoT. That's it. Save. Do the same with BR-guest and BAT0.4, then BR-LAN and BAT0.99. You may use different numbers. I have just chosen them arbitrarily. On the BR-LAN bridge, I have also added the Ethernet ports. Cool. Now over to the Interfaces tab. I click on Edit next to each interface and make sure that each interface is linked to the right device. Again, BR-IoT for IoT, then BR-guest for guest, and so on. Perfect. Now let's click on Save and Apply and do this on all nodes. What should now happen is that the IoT and guest interfaces get assigned IP addresses from the main router's DHCP server. It might take a minute. Here we go. All good. Do this on all access points and routers. Quick tip here. If you have multiple devices of the same brand, make and model, then you can accelerate the configuration if you take a backup of the first node and restore to the others. You would still have to install the software packages, but it will save you a lot of clicks. If we look at the blueprint again, here's what we have just done. The Batman interface carries the mesh traffic, and we attached all interfaces of guest, IoT and LAN to the right sub-interfaces, or rather VLANs. We now have a working mesh that can run over Wi-Fi or wire, or like in my case, mixed architectures. Let's test it. When I set up the Wi-Fis, I had also activated fast roaming or fast transition. You can do that by ticking the 802.11r tick box under Wi-Fi security. Just choose a 4-digit mobility domain, which has to be the same on all access points for a given network. That means it has to be set to the same on all IoT, then a different value for all guest, and so on. Select FT over the air in the FT protocol dropdown. These settings will accelerate the handover from one access point to another. What I want to do next is that I walk around the house with my mobile phone. The phone should then quickly roam from one access point to another and keep me connected at any time. On the phone, I will run an iPerf3 speed test and measure the bandwidth. Just before I do that, let me show you an important tool of the Batman Advanced network. This is a command line utility called batctl, short for bat control. This utility gives me a lot of insight into the mesh. I can, for example, show all the participating mesh nodes or originators with batctl originators, or short batctlo. This shows all my access points and the router. Or I might want to see the available internet gateways in my mesh by typing batctl GWL, which is short for gateway list. Look what happens when I change the gateway bandwidth on my router with batctl GW. The info gets replicated instantly to all nodes. I can do things like show all MAC addresses in the MAC table and even measure throughput between nodes, and so on and so on and so on. In order to make this a bit more readable, I can actually create a BAT hosts file that would then show host names rather than just MAC addresses. Here's the output. What I am after is this info here. I want to see the next hop to my mobile phone. As I walk around, this should change automatically without me noticing. So here on the screen, you see the output of the transglobal table showing the next hop to my iPhone, and down here, the iPerf3 throughput that I have with my phone. As I walk around, the next hop changes, and occasionally the speed does, depending on how many nodes I'm actually connected to. Now I will be walking around my Wi-Fi mesh, which I actually had to extend to my 3 floors and the garden to make it a bit more real-world size. Everything is on the 5 GHz band, so roaming should occur quite frequently here. Just as an overview, here is the complete plan of the mesh. I have 6 of these Lyra access points, Lyra 1 on the first floor of my house, Lyra 2 in the basement, Lyra 3 at the ground floor level, plus Lyra 4, 5 and 6 positioned at windows around the house. I have the router in the middle, which does not participate in Wi-Fi. Lyra 1, 2 and 3 are wired to the router. Now watch how everything moves. You can see my phone roaming from one mesh node to another in the top window, and in the bottom window you can read the throughput from iPerf3. please do keep in mind that the access points are all inside the house and I'm walking around the house outside. It's all thick concrete walls here, so sometimes the performance drops badly. But this is not meant to be a speed optimization, but rather to show the transparent handoff from one node to another. Even though I have noticed some seconds of outage, I might need to check on all parameters such as the mobility domain for fast roaming and the used channels. Also, using a high 5 GHz channel as the backbone might not be the best solution in my concrete bunker here. I would probably be better off with a 2.4 GHz backbone. Last but not least, I have not yet optimized anything for fragmentation. That means that all the MTUs on the whole network are 1500 by default, which of course lowers the performance considerably. But I think you get the idea. So, overall conclusion. The Batman Advanced network can be used to spawn a mesh of virtually any size over multiple nodes in a mesh, be it wired or wireless or hybrid. At the same time, the Batman Advanced driver transforms the mesh into a giant managed switch. You can plug in any interface anywhere to any VLAN on that switch. You could use this to build a mesh with Wi-Fi and wired portions like I just did, or, because you can have multiple gateways on that mesh, you could use it to build a community mesh, be it a large house with multiple parties, or a whole street or a city. It doesn't matter. Everyone could still have their own Wi-Fi name, etc. on different VLANs, just the parties could share all their internet gateways. So, rather than having a combat over free Wi-Fi channels, you could actually share them in an intelligent way and provide better Wi-Fi to everyone. Having said that, that's all I wanted to show you today. Thanks for watching. Stay safe, stay healthy. Bye for now. Leave me a like and a comment. Bye bye.